All right, and welcome back to our third video here dealing with some of our quantitative graphs. Earlier we did a histogram. We looked at how we could create one of those, and now we're going to be looking at what's known as a box plot, or some of you guys hear it as a box and whisker plot. Either one works. So we're going to be using this one as our example here on our box and whisker plot. It's called that because it has our box and the whiskers, and if you draw out that same line, it really does look like whiskers coming out. So that's how it got its name. But let's talk about what does all this mean? Because it's actually a quantitative way to write our graph. And you guys see that some of these boxes can sometimes be really long, sometimes they can be squat, sometimes your whiskers are super long, other ones are short, sometimes you have dots out to the side. And what does this bar in the middle of our box actually mean? So first off, for a box plot, you're always going to need 5 numbers to really define it, and it's called its five number summary. So the edges that you're going to do is always going to be what is your minimum data point and your maximum data point. So those are going to be the first 2 of your 5 number summary, and those go on the very end. The number that represents the very middle of your data is known as your median. This is where you line up all your data from lowest to highest, and the number that's actually smack dab in the middle is your median. But you can also do that same process for everything between your minimum and your median, and everything between your median and your maximum. You can line all of those up and say, hey, out of these numbers, which one is smack dab in the middle? The first one on the lower inside is known as your Q1 or quartile 1. And the one on the top side is known as your Q3 or quartile 3. And that's because you can see our data is actually split into 4 pieces. You have the whisker, the first box, the second part of the box, and the second whisker. And so those are your quartiles. This whisker actually represents the bottom 25% of your data. This box represents the kind of that mixture between the bottom 25 and your halfway mark. So that's where this data is. So from the mark here all the way out, this is the bottom 50% of your data. This side is the top 50% of your data, with it being split into 2 parts, this being the top 25% of the data. So that's kind of what a box and whisker plot shows. It shows you how far apart is the data for each of these chunks. And each of these lines has exactly the same amount of data points that falls here, 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 and here. But we can see that for this data set, because this is a short line, the bottom 25% of our data is actually clumped pretty close together, as well as this part. The bottom 50% actually looks to be about the same distance as maybe this middle part here. So it might actually be a little bit longer. So the top part of our data is really spread out. That's why we have this long whisker and this long box. The bottom part of it is a little bit more clumped together. So this is what we're talking about when you talk about your 5 number summary. You're going to give us your minimum. What is your absolute middle number, your median, your maximum? Then you can do that median kind of process again between the median and your maximum and find that middle number. Between your median and your minimum, find that middle number. So these are a lot of the parts that go with it. I did kind of just mention out what each of these are, so let's kind of zoom in again so we can look at this in a little bit more detail. We said you're always going to start here with your minimum number. So my minimum was 5, this is where it's going to go. We then plot our Q1. Between your Q1 and your minimum is going to be your whisker. Your Q1 starts the box. You're going to have another vertical line where your median is. This line here always represents your median. This weird line that gets drawn in the box shows you where is your median. You can then also draw another vertical line for your Q3, and that's when the other edge of your box. So your box is created by your quartiles. This length is actually going to be known as our interquartile range. We're going to talk about that. This represents the middle 50% of the data. So the bottom 25, the top 25, the middle 50%, with the median splitting it in half. Your whisker here then is your top 25% of your data. It typically ends with your maximum, but our maximum here is actually an outlier. Whenever you have a dot just like this out to the side, it's known as an outlier. So let's actually talk about how we can find our outlier in this interquartile range. So it says here that your interquartile range, it makes sense if you think about it, interquartile, so between your quartiles, the range, what goes to it. So all you have to do is subtract your Q3 from your Q1. Now some people are like, how do I know which one goes first? You just do your larger minus your smaller of your quartiles, and it's going to tell you how long the box is. how long your box is known as your interquartile range. It is the range that the middle 50% of your data falls into. Now, one of the reasons we need to know the interquartile range is because it helps us determine if we have any outliers. So many people, if you're using the Boxplot, it is called the 1.5 IQR rule for outliers. And if you think about it, it's going to be 1.5 times our IQR. That's how we're going to determine our outliers. So one of our data points is an outlier if and only if it falls more than 1.5 IQR above Q3. I have that written in the small words. I guess I could write out third quartile there. Or below Q1, which is our first quartile. So even though this is given to in words, sometimes it's helpful to see what does that actually look like. So I'm going to zoom in again, and we're going to use this data to actually show why this guy was an outlier. So the very first thing I need to do is I need to find my IQR. So all I'm going to do is out to the side, I'm going to take my Q3, and I'm going to subtract it from my Q1. And when I do, I get 27.5. So my IQR is 27.5. All of my middle percent of my data falls within 27.5 points of each other. And this is representing data time, travel time. So those would be within 27.5 minutes of each other is where the middle of my data is. Now, in order to figure out the IQR for outliers, we have to actually take this number and multiply it by 1.5. I'll actually change colors for this bit. So we're going to multiply it by 1.5. When I do that, I get that 1.5 of my IQR is equal to 41.25. That makes sense. We multiply it by 1.5, so 1 times half of itself. Slightly larger number, but not double what we had. Now this number says this is the furthest away from your quartiles that you can be. This is as long as my whisker can be. My whisker cannot be longer than this distance. If my whisker is longer than this distance, that's actually an outlier. I would plot that one by himself, and my next lowest data point is going to be where my whisker ends. So to determine if this is actually correct, we have to take our quartiles. So once again, I'm going to take this 42.5. And we have to add or subtract this number. Obviously, if we're going into larger numbers here, I'm going to add it. So I'm going to add 42.5 and 41.25. So I'm taking, once again, my Q3, this edge number here. I'm adding this 1.5 IQR because that's the longest my whisker can be. And we're going to see, do all of my data points fall there? When I added these together, I got 83.75. So in order to not, once again, in order to not be an outlier, you have to be beneath this number. And so as I come looking at the top part of my data, I see that I have the data point 85. 85 is larger than this number, so it is going to be an outlier. It is larger than my quartile plus this 1.5 IQR, so plus 1.5 the length of my box. And it's larger than that, so it's going to be an outlier. Because it's an outlier, I plot it by itself. And once again, I look back at my data and say, what is my next highest data point? That's 65. He's not an outlier. He's less than this number, so he's good. That is where my whisker is going to end. But to check for outliers, we actually have to check both sides. Now, this looks pretty small, so we know it's not really going to have one, but let's just double check. So for this side, I'm once again going to take this quartile, the 15. Here, I want to go to lower number, so I'm going to subtract the number. So I'm going to subtract the 41.25. When I do that, I get negative 26.25. Now, immediately, I know that this is talking about travel time, and I'm not going to have a negative travel time. So I'm not going to have any outliers here. It's impossible to have a number that's here. But we can double check just to be on the safe side. So there you have it. This is a box plot. You put all of your numbers in order, and this actually represents how far away are the data in each of these chunks. Once again, your whisker is your bottom 25%. This whisker is your top 25%. And then the box represents that middle 50% with the median splitting in half. We're going to check for our outliers to make sure that we don't have any, or if we do, we plot them by themselves, and then your next highest or on the side, your next lowest would be the end of where your whisker goes.